About 15 years ago I designed this, and for anyone that hasn't followed my channel, this is a transistor microprocessor, and it contains about 2,000 transistors, and the only IC in this entire construction is the ROM, but it's a fully functional microprocessor. It's got decoder, ALU, accumulator, all the things you would find in a normal microprocessor. It's fully functional, and I designed this because I wanted to see how difficult it would be to design a microprocessor using just bipolar transistors. And that was the point. I wanted to use bipolar transistors because back when they were in heavy use, that is of course what was available, and that's really what I was trying to target this for. It wasn't designed to run at high speed. It ran up to about 250 kilohertz, and I have since been asked many times how fast could it actually be made to run. So a few months ago I posted a video showing how to increase the switching speed of a bipolar transistor, and that was the intention, was just to show what you could do with this if you wanted to kind of rearrange the circuits for each individual transistor. And I think we've got them up to about 20 megahertz or something, so you could make this run very significantly faster. Now I did have some comments on that video saying, well, could you just replace the bipolar transistor with a CMOS device? Of course, you could replace it with something like this. This is a 2N7000 series device, not a bipolar transistor. So the reason that I said this wouldn't be suitable, for two reasons really, two main reasons. Firstly, if I was to post a video saying, for example, let's take this and I'm going to make it go twice as fast. So we're going to redesign it to go much faster. Here's the blueprint for it, so we'll use that as our starting point, and we'll go through a redesign, and I'm going to demonstrate how to make this go twice as fast. So after a bit of research and development, here's my solution, and it now goes twice as fast. Now of course that's a bit of tongue-in-cheek, but the point is, this is not a bipolar transistor. However, the comment was correct. You could make this processor out of these, but you can't do it just by replacing the bipolar transistors. I did release a book that shows the schematics and circuits for this and explains how it all works. And it's not as straightforward as it might appear. There's a lot of interaction between the various parts of this, and if you were just to drop these in, it wouldn't work. And I did post that in a reply to the comments, and I think most people accepted that. But I just thought I'd clarify exactly what the issue is in light of a recent comment that was made off the back of the response I gave. So this is the comment I received. I've redacted the name. I'm not going to say who posted this. I'll let you pause the video and read it if you really want to. But this character is clearly just a troll, and in fact I went to his YouTube channel. He's got one video posted that's entitled something like "How to Troll Like a Professional." Very sad reflection on society that people have such small minds that they think that's a good thing. But the way these idiots normally operate is to look through all the negative comments that have been made on a particular video, put them all into one response that they don't understand, and you'll get something like this. But this does cover a range of comments that I received, albeit not as rude as this, and I thought I'd just respond to this and say exactly what the issue is. It might be quite interesting. So the first thing is, yes, I said that the 2N7000 cannot just be dropped into this. Now I'm going to demonstrate why that is. So what I've got set up here, and also why you could use it if you wanted to redesign the system. So what I've got set up here is a bipolar transistor, the same type that we've used in the processor. got it hooked up to my Juntec, and we've got this set at the moment to 10 kilohertz. We've got the scope, blue channel's the input to the transistor, and the yellow channel is the output from this. This is just a very simple switching circuit, and as you can see it works fine, and I can just swap this out with a 2N7000 and it will work just fine. You can see no difference whatsoever, which is what some of the comments were saying, and I totally agree. That's something you can do, and you do have the advantage. So again, the comment was correct in that if we start increasing the frequency, so we'll go up to 100 kilohertz, and again this is using a bipolar transistor, it's still fine at 100 kilohertz. If we go up to 200 kilohertz, you can see we're now getting into the region where the switching is a lot slower, and I explained what's causing this in the video that I posted originally, so I won't go back over it here, except to say that, as you can see, it's starting to struggle to switch. So we'll go up to 300 kilohertz, and you can see now it's not really switching. I showed in the video how you can get around this and make it switch reliably up to 20 megahertz. But the comment that was posted was, could you just swap it with these? And the answer is, of course, yes you could. And it now still works. Won't go that much faster, to be honest. You'll get up to maybe a megahertz if you're very lucky, but beyond that you'll really start to struggle. So, but that wasn't really the problem. The reason I say you can't just drop it into the processor, and I did qualify this with the response that I gave, is I said you can't just put these devices into complex circuits without redesigning the circuits, and I thought I'd just demonstrate what the general effect of that would be. So I've got a very much simplified circuit here for one of the gates in the transistor processor. We'll move the clock and the scope so we are reading the output of that particular gate. Okay, so this currently has bipolar transistors as the switching elements, and as you can see it's working just fine. The yellow trace is the output, and if we move the, let's get rid of these, if we move the second input of the gate to low, you'll see it's still switching, and importantly the threshold we're looking at here is still sufficient to allow the output to switch the following stages. And that's kind of the point, is it has to work in each of the modes it's expected to run in. If we just simply swap these devices out with the CMOS switches, so now I'll put the 2N7000s in here. Okay, so firstly it seems fine in this mode. It's actually not switching properly, but so the following stage wouldn't be switching, it would be constantly on. But if we move across to the other potential input combination, you'll see that the output is significantly lower. So although it's switching, which it will do, it is similar in its operation to a bipolar transistor in this mode. It will not work reliably in the transistor processor, and this is a very simple circuit. This effect gets far worse as we get into the more complex circuits, and bear in mind some of the circuits in the transistor processor have up to 40 transistors in them. So if you start multiplying this effect that we're seeing here, then very quickly the transistor processor wouldn't work. In fact, this wouldn't work anyway. If we tried feeding this into a follow-on stage, then it wouldn't be working. Now let's go back to the bipolar ones, and hopefully you can see the difference. You can see we're getting a much better signal, and if we go to the second mode of input, you'll see we're getting much better switching. So the whole point is that in a simple single element switching circuit, then yes, the 2N7000 wins hands down, that's not a problem. But my video was about how to increase the switching speed of a bipolar transistor, not how to replace it with something completely different. Now on to the second part of this, which is really the cost. Yes, I completely agree that if you buy from a middleman or through a middleman, the cost will be higher. I've been running my own businesses and manufacturing for many decades, so I'm fully aware of this. However, the prices I quoted in the response I gave were both from middlemen. So I was doing a like-for-like comparison, not some dim-witted response like this, which is just word salad. So the point is, if you go back to the original manufacturer, then yes, you can get a better deal. But the same is true of the devices I used in the transistor processor kit. So the entire context and point behind this is idiotic, and this is the sort of response I said quite a few years ago in a video: try to avoid millennial arguments. And this is a classic example of a millennial argument. It's someone just making noise without having understood the response. So if you did make a comment and say, could you use 2N7000s, then yes, you're absolutely correct, you could. You couldn't use it without modifying the rest of the design, and that would be quite a significant change. The way that some of the circuits work do only really work properly with bipolar transistors. You would need to completely redesign it to use something like this. And in terms of the speed, yes, the 2N7000 is inherently faster, but that was not what the processor was designed to do. It wasn't designed to run at high speed, and also it was intended to use bipolar transistors. So I'm hoping that fully answers the questions and comments that were raised. Okay, so I'd fully encourage anyone, if you want to try and redesign something like a microprocessor using devices like this, see how fast you can get it to run. I think that would be extremely interesting. But that's not what my video was about. It was about increasing the speed of bipolar transistors.